So we'll talk a little bit about science pedagogy in the classroom, so using different methods, what is effective, what kinds of things are being proposed to be effective in the classroom. But what I like to do is always go back to this documentary that was produced by the Annenberg CPB project in cooperation with the Smithsonian Institution in the US and Harvard, famous university in the Northeast. So I'll show you a segment of this, and then what the problems are. We can discuss what the problems are with this one segment, as you'll see here. But the name of it, that's the name of this documentary. So if you type in Google, if you type in lessons from thin air, you'll get the link. It's free to play. It's about an hour. And it comes from a series of documentaries that were made that I think today are still the best science education documentaries ever made. So you could take away the haircuts and the clothing style and everything else, and the same exact issues that existed when they made this documentary exist in the classroom today. The same things. So that's the name of it. I'm gonna skip forward to this one part here.
Here's a seed.
Okay.
Okay? Now hold on to that for a second.
Okay.
Imagine that I planted that in the ground.
Okay.
And a tree grew. All right? And here is a piece of that tree.
Sure.
Okay? Now where did all that stuff come from?
So where do plants come from? You look at these beautiful big redwood trees, these great spreading valley oaks, and you know they start from this little tiny seed. It's miraculous. Where does all that weight come from?
Well, the mass came from a lot of things, I'd guess. I'd guess from water that it sucked up from the ground. I would guess from minerals that it sucked up from the ground.
Water, light, soil.
Well, I suppose in terms of raw mass, most of it's probably derived from actually matter in the soil itself, and some of it comes from water, obviously, but a large amount of it comes from the nutrients that the roots absorb from the soil.
Now what would you say to someone who said to you that most of the weight of the tree came from the carbon dioxide in the air?
I would say I would have no idea. I'd have to think about that.
I would disagree because this same volume of air wouldn't weigh this much unless it was highly compressed. I said that's very disturbing and wonder how that could happen.
It's a very strange idea that somehow the air, which they view as nothing, as weightless, as insubstantial, somehow makes a tree, a giant tree that weighs several tons. I mean, it's absolutely incredible.
That'd be hard to believe because carbon dioxide is, well, it's a gas, and it doesn't seem intuitive that you could add mass taking in a gas.
And they asked these students at graduation who are obviously smart. They graduated from Harvard. They've been through a lot of schooling for 16 years. But they all missed something, right? They all said water, nutrients, soil. Some of them said sunlight. So what was it they missed? All of them. Carbon. Not a single one of them said carbon from the atmosphere. You ask college students today, because I teach almost every semester, biology class to juniors and seniors, right, that are going into science education. So they're going to become teachers, okay? Same exact answer. Same exact answer. Water, soil, nutrients, some mention sunlight, some mention air, but they don't mention carbon. Now, here's the really tough question. So I just want you to think about just respond to something here. Why not? Why don't they mention that? Yes, okay, so number one, it's invisible. Very good. What else? It's invisible. That's a big part of it. What's another reason? Something that gets more to the pedagogy of the way we've approached we'll just say it now, the way we approach photosynthesis. A very common thing to be taught, right? From maybe 9, 10 years old all the way through college.
They don't put it in the right context. Like it's all, everything around you is dependent on the
Yes, okay, so context is the major thing here. Why don't they put it in the right context? It's a very specific thing, the way we teach photosynthesis. Think about the way you were taught photosynthesis. What did you do? Or maybe you were teaching photosynthesis. What do you do? So it's one reaching into your past, and one, if you're teaching it, what are you doing? Yes, it's the way you demonstrate it. Oh, you're so close. What is the classic way that we have all taught photosynthesis, if you've taught it? Okay, drawing. Okay, so at lower, elementary level, right? We might start with a diagram. Very good. Excellent. What's the other way that's very classical? So you got the sun, leaf, right? Atmosphere, leaf, product. What's that?
something on the one side and something on the other side with the arrows.
The equation for photosynthesis, right? So how many times did these students write invisible? And a lot of students, because they're invisible, don't think they have what? Mass. Very good. They don't think they have mass. They don't, quote, matter. It's a bad pun, I know, but it's late Saturday afternoon, So they don't matter. But didn't elementary students study gases, liquids, solids? But how many times did they get to hold those? Okay, in some way. So you have to create physical context for it to be meaningful. This equation is not meaningful. Does that make sense? Doing things related to that equation is meaningful. So here's the reaction when they're told. Okay, so I know you have to listen carefully. So even though he's written the equation, right? When somebody tells him that's the right answer, even though he's written the equation, that equation is not running through his brain right now. He's not even thinking about photosynthesis and what were the reactants and what were the products. It's not part of his understanding. Otherwise, he would be like, oh yeah, well, carbon dioxide gas helps make the bulk of the tree. Some basic answer like that, right? So this is where we lose all this context when we rely on the equation to teach photosynthesis, instead of us teaching the components of the equation and then letting our students teach themselves about photosynthesis. So at the beginning, if you rely on that, you're up for a losing battle. It's been shown by this documentary and by the students I question about this every year. First day they walk in, I show them that segment and I stop it and I go, write your answers down.